What is chaos engineering?
Chaos engineering is the discipline of experimenting on a distributed system to build confidence in its ability to withstand turbulent conditions in production. It involves deliberately introducing controlled failures to identify weaknesses before they cause real outages. The goal is not to break things, but to learn how systems behave under stress and improve their resilience.
What are the principles of chaos engineering?
The key principles include building a hypothesis around steady-state behavior, varying real-world events like server failures and network issues, running experiments in production, automating experiments to run continuously, and minimizing the blast radius. You start by defining what normal looks like, then introduce failures and observe whether the system maintains that normal behavior.
What is steady state in chaos engineering?
Steady state is the normal operating behavior of a system defined by measurable business metrics, such as request rate, error rate, latency, and throughput. Before running a chaos experiment, you establish the steady state as a baseline. During and after the experiment, you compare the system's behavior against this baseline to determine if the system is resilient to the injected failure.
What is Chaos Monkey?
Chaos Monkey is a tool developed by Netflix that randomly terminates virtual machine instances in production to test the resilience of services. It was one of the first chaos engineering tools and is part of Netflix's Simian Army. By randomly killing instances during business hours, teams are forced to build services that can tolerate individual instance failures without impacting users.
What is the Netflix Simian Army?
The Simian Army was a suite of chaos tools created by Netflix. Chaos Monkey killed random instances. Chaos Gorilla disabled entire availability zones. Chaos Kong simulated regional outages. Latency Monkey injected network delays. And Conformity Monkey identified resources that did not adhere to best practices. Most of these tools have been retired or replaced by newer chaos engineering platforms.
What is Litmus Chaos?
Litmus is an open-source, cloud-native chaos engineering framework for Kubernetes. It provides a library of pre-built chaos experiments as Chaos Engine custom resources, a chaos hub for sharing experiments, and a web portal for managing and observing experiments. Litmus integrates with CI/CD pipelines and supports experiments targeting pods, nodes, networks, and applications.
What is Gremlin?
Gremlin is a commercial chaos engineering platform that provides a comprehensive set of failure injection capabilities, including resource attacks like CPU and memory stress, network attacks like latency and packet loss, and state attacks like process killing and time travel. It offers a SaaS platform with scheduling, team management, safety controls, and detailed reporting.
What is Chaos Mesh?
Chaos Mesh is an open-source chaos engineering platform for Kubernetes, originally developed by Ping CAP and now a CNCF incubating project. It supports pod chaos, network chaos, stress testing, I/O chaos, and time chaos. Chaos Mesh uses Kubernetes custom resources to define experiments, provides a dashboard for visualization, and integrates with Grafana for monitoring experiment impact.
What is a WS fault injection simulator?
A WS fault injection simulator, or FIS, is a managed service for running chaos engineering experiments on a WS resources. It supports injecting faults into EC2 instances, ECS tasks, EKS pods, RDS databases, and network infrastructure. FIS provides safety controls like stop conditions, integrates with CloudWatch for monitoring, and requires IAM roles to limit the scope of experiments.
What is a chaos experiment?
A chaos experiment is a structured test that introduces a specific failure into a system while monitoring its behavior. It follows the scientific method with a hypothesis about what should happen, an action that introduces the failure, observation of the system's response, and analysis of results. Experiments should have a clear scope, rollback plan, and success criteria defined before execution.
How do you design a chaos experiment?
Start by identifying a steady-state hypothesis about your system's behavior under normal conditions. Choose a failure scenario relevant to real-world risks. Define the blast radius and duration of the experiment. Set up monitoring to observe the impact. Run the experiment and compare actual behavior to the hypothesis. Document findings and create action items for any weaknesses discovered.
What is blast radius in chaos engineering?
Blast radius refers to the scope of impact of a chaos experiment on the system and its users. Starting with a small blast radius, such as a single pod or instance, minimizes risk while still providing useful insights. As confidence grows, the blast radius can be expanded to entire availability zones or regions. Controlling blast radius is essential for safe experimentation in production.
What is a game day?
A game day is a planned event where teams simulate real-world failure scenarios to test their systems and incident response processes. It brings together engineering, operations, and sometimes business teams to practice responding to outages. Game days combine chaos experiments with incident management exercises, helping teams identify both technical weaknesses and process gaps.
What types of failures can you inject in chaos experiments?
Common failure types include infrastructure failures like instance termination and disk failures, network failures like latency injection, packet loss, and DNS failures, application failures like process crashes and memory leaks, and dependency failures like database unavailability and external API timeouts. Each type tests a different aspect of system resilience and helps uncover different classes of issues.
What is CPU stress testing in chaos engineering?
CPU stress testing artificially consumes CPU resources on a target host or container to simulate high CPU utilization scenarios. This reveals how applications behave when CPU-starved, whether autoscaling responds appropriately, and if resource limits and requests are properly configured. Tools like StressNG or Chaos platforms inject CPU stress with configurable intensity and duration.
What is network latency injection?
Network latency injection adds artificial delay to network packets between services to simulate slow networks, overloaded dependencies, or cross-region communication delays. This helps identify timeout misconfigurations, missing retry logic, and cascading failures caused by slow dependencies. Experiments typically start with small delays and gradually increase to find the breaking point.
What is packet loss injection?
Packet loss injection randomly drops a percentage of network packets to simulate unreliable network conditions. This tests how well applications handle retransmissions, whether protocols degrade gracefully, and if users experience acceptable performance under network degradation. Even small packet loss percentages can significantly impact application behavior, making this a valuable experiment.
What is DNS failure injection?
DNS failure injection simulates DNS resolution failures to test how applications handle the inability to resolve hostnames. Many applications assume DNS always works, so DNS failures can cause unexpected crashes or cascading failures. This experiment reveals missing DNS caching, inadequate timeouts, and lack of fallback mechanisms in service discovery.
What is process killing in chaos experiments?
Process killing terminates specific application processes on target hosts to test restart mechanisms, supervision strategies, and failover behavior. This simulates application crashes and verifies that process managers, container orchestrators, or systemd restart the process correctly. It also tests whether the application handles graceful shutdown and startup properly.
What is disk failure simulation?
Disk failure simulation introduces I/O errors, fills disk space, or makes file systems read-only to test how applications handle storage issues. This reveals whether applications fail gracefully when disk space is exhausted, whether monitoring alerts on disk issues, and whether logs and data are handled correctly during storage failures. These experiments are important for stateful services.
How do you run chaos experiments safely in production?
Safe production experiments require abort conditions that automatically stop the experiment if metrics breach thresholds, a limited blast radius that starts small, proper monitoring, and alerting, a tested rollback mechanism, team communication about the experiment, and running during business hours when teams are available to respond. Never run experiments without the ability to immediately stop them.
What are abort conditions in chaos experiments?
Abort conditions are predefined thresholds that automatically stop a chaos experiment if the system's health degrades beyond acceptable limits. Examples include error rate exceeding a percentage, latency crossing a threshold, or a health check failing. Abort conditions act as a safety net that prevents experiments from causing real outages and should always be configured before running experiments.
How does chaos engineering relate to resilience testing?
Resilience testing validates that a system can recover from failures, while chaos engineering proactively discovers unknown failure modes through experimentation. Resilience testing is typically pre-planned with known scenarios, while chaos engineering explores unexpected behaviors. Both practices complement each other, with chaos engineering findings often becoming new resilience test cases.
What is the difference between chaos engineering and fault injection testing?
Fault injection testing introduces specific known failures to verify expected recovery behavior, while chaos engineering uses a broader experimental approach to discover unknown weaknesses. Fault injection asks, does the system handle this specific failure? While chaos engineering asks, what happens when we introduce this turbulence? Chaos engineering may use fault injection as a technique but has a broader exploratory goal.
How do you measure the success of chaos engineering?
Success is measured by the number and severity of weaknesses discovered, improvements made to system resilience, reduction in mean time to recovery for real incidents, increased confidence in system behavior, and cultural adoption of resilience thinking. Tracking metrics like the number of experiments run, findings per experiment, and time to remediate provides quantitative measurement of the program's effectiveness.
What is chaos engineering in CI/CD pipelines?
Integrating chaos experiments into CI/CD pipelines automatically runs resilience tests as part of the deployment process. Tools like Litmus and Chaos Mesh support pipeline integration, where chaos experiments run against new deployments in staging or canary environments. If the application does not maintain steady state under the injected failures, the deployment is blocked or rolled back.
What is the role of observability in chaos engineering?
Observability is essential for chaos engineering because you need to understand how the system responds to injected failures. Metrics, logs, and traces provide visibility into the impact of experiments. Without adequate observability, you cannot determine whether the system maintained its steady state. Chaos experiments often reveal gaps in observability that need to be addressed.
How do you build a chaos engineering culture?
Building a chaos engineering culture starts with leadership support and education about the practice's benefits. Begin with small, low-risk experiments and share the findings broadly. Celebrate discoveries rather than blaming failures. Conduct game days to involve the wider team. Make it easy to run experiments with self-service tools. Gradually expand from staging to production as confidence and skills grow.
What is the difference between proactive and reactive chaos engineering?
Proactive chaos engineering runs experiments before failures occur in production, discovering weaknesses while there is time to fix them. Reactive chaos engineering involves analyzing past incidents and creating experiments to verify that fixes actually prevent recurrence. A mature program combines both approaches, using incident learnings to design new experiments and proactive testing to prevent new failure modes.
What is Toxaproxy?
Toxaproxy is a tool developed by Shopify for testing network conditions between application components. It acts as a TCP proxy that can inject latency, limit bandwidth, add jitter, inject timeouts, and simulate connection resets. Toxaproxy is particularly useful in development and testing environments for validating application behavior under various network conditions before deploying to production.
What is Powerful Seal?
Powerful Seal is an open-source chaos testing tool for Kubernetes that can kill pods, delete nodes, and inject network failures. It supports 3 modes of operation: interactive mode for manual exploration, autonomous mode for continuous policy-based chaos, and label mode for targeting specific resources. Powerful Seal integrates with Prometheus for monitoring experiment impact.
What is the Swiss cheese model in the context of chaos engineering?
The Swiss cheese model describes how system defenses are like slices of Swiss cheese, each with holes representing weaknesses. Failures occur when the holes align across multiple layers, allowing a problem to pass through all defenses. Chaos engineering identifies these holes in individual layers, so they can be patched before they align with holes in other layers to cause a real outage.
How does chaos engineering help with disaster recovery?
Chaos engineering validates disaster recovery plans by actually simulating the disasters they are designed to handle. Instead of trusting that failover will work based on design alone, chaos experiments verify it works in practice. This includes testing database failover, cross-region recovery, backup restoration, and communication procedures. Game days for DR scenarios reveal gaps that paper exercises miss.
What is zone failure testing?
Zone failure testing simulates the loss of an entire availability zone to verify that applications can continue operating with reduced capacity. This involves terminating all instances or pods in a specific zone and observing whether traffic automatically reroutes to healthy zones. It tests zone-redundant architectures, auto-scaling responses, and data replication across zones.
What is dependency failure testing?
Dependency failure testing simulates the unavailability or degradation of external dependencies, such as databases, third-party APIs, and caching layers. This reveals whether applications have proper circuit breakers, fallback mechanisms, and graceful degradation strategies. It is one of the most valuable chaos experiments because dependency failures are among the most common causes of real-world outages.
How do you prioritize which systems to test with chaos engineering?
Prioritize systems based on business criticality, complexity, and the consequences of failure. Start with revenue-generating or customer-facing services. Focus on systems with many dependencies recent changes, or a history of incidents. Consider the blast radius of failures in each system. Use risk assessment frameworks to evaluate which systems would benefit most from chaos testing.
What is a hypothesis in chaos engineering?
A chaos engineering hypothesis states your expected system behavior when a specific failure is introduced. It follows the format, given this steady state, when this failure occurs, the system will continue to operate within these parameters. A well-formed hypothesis is specific, measurable, and based on the system's design assumptions. The experiment either confirms or disproves the hypothesis.
What is continuous chaos?
Continuous chaos is the practice of running chaos experiments automatically on a regular schedule rather than as one-time events. Automated experiments detect regressions in resilience as the system evolves. Tools like Litmus, Gremlin, and Chaos Mesh support scheduled experiments that run continuously and alert when the system fails to meet its resilience expectations.
How does chaos engineering relate to SRE practices?
Chaos engineering complements SRE practices by proactively testing the reliability assumptions that SRE is built on. SRE defines error budgets and SLOS, while chaos engineering verifies the system can actually meet them under adverse conditions. Chaos experiments can consume error budget in a controlled way, and SRE incident reviews often generate new chaos experiment ideas.
What is the difference between chaos engineering and staging vs production?
Staging experiments are safer, but may not reveal issues that only appear in production due to differences in scale, traffic patterns, and configuration. Production experiments test the real system, but require careful safety controls. Best practice is to start in staging to validate the experiment design and safety mechanisms, then graduate to production with tight blast radius controls and abort conditions.
What is chaos engineering for serverless applications?
Chaos engineering for serverless applications focuses on testing function cold starts, timeout behavior, concurrency limits, dependency failures, and event source disruptions. Tools like the Failure Lambda injection library inject failures into Lambda functions. Unique challenges include the lack of infrastructure control and the need to test platform-specific failure modes like throttling and provisioned concurrency limits.
How do you document and share chaos engineering findings?
Findings should be documented in a structured format including the hypothesis, experiment setup, observed results, impact on users, and recommended actions. Share findings through team presentations, incident review processes, and a centralized experiment registry. Creating runbooks from chaos findings ensures the knowledge is actionable. Publishing results across the organization encourages a culture of resilience.
What is the relationship between chaos engineering and performance testing?
Performance testing measures system behavior under expected load, while chaos engineering tests behavior under unexpected failures. They are complementary because a system may perform well under load, but fail under combined load and failure conditions. Some organizations combine both by running chaos experiments during load tests to understand how failures affect performance at scale.